Okay, so in this video, we're going to discuss, what is science? What is science? And then we're going to progress into the scientific method, the steps that are used to collect information. So let's go ahead and get started. What is science and what is the scientific method? All right, so what is science? Well, a very vague definition of science is that it's a process that produces information about the natural world. And I do want to stress the phrase the natural world because there's kind of a argument going on about should we allow the supernatural into science. And that's an argument we're not going to pick up in this video. But currently, absolutely, we only look at the natural world. We don't allow the supernatural to explain the natural processes. One thing about science is that it's supposed to be objective, and that can be very hard for people because we often come into an experience with a bias. We come into an experience with a preconceived idea of what we think is the answer, and people don't usually like to be wrong. And so that's one of the harder parts of science, is to look at something objectively, to come in with a fair and balanced expectation. If you come in with a bias, well, that bias might weigh you down and kind of force you to ignore the reality. That's one of the harder parts of science, which is the reason why in science you, of course, share your results with others. In case you do have a bias, hopefully your bias will be uncovered by someone else. One thing about science is it needs to be repeatable. I just brought up that often science experiments and data learned are published in journals and shared around the world. Well, that's so others can repeat their experiments to see whether or not the idea is correct. One thing about science is that there are certain tools and skills that are used to gather information, and probably one of the more obvious ones is the skill of observation. Here we have people doing microscope observations, trying to uncover more secrets of the microscopic world. Here we have pretty much just the opposite, using a telescope to peer into the nighttime sky and uncover secrets of the universe. In this case, we have a picture of one of the Voyager probes that was launched in the 1970s. And these things have been drifting around in our solar system and now beyond since the 1970s. And they've observed the solar system and sent back to Earth the data that's been collected. So there's all kinds of observations that can be done. And let's not forget one of the more famous observations. Here we have a little drawing of Isaac Newton, and an apple just bumps him on the head, and that observation of a falling apple led him to uncover this force in nature called gravity. Well, another skill, another tool that is used in science is simply experimentation. And in our picture here, we have a young lady doing an experiment on DNA electrophoresis and using electricity to separate small bits of DNA so that those pieces of DNA can be analyzed. In this pretty famous experiment that took place in 1928, a gentleman by the name of Frederick Griffith taught us that bacteria can transfer genetic information. In the picture, he injected mice with a non-deadly bacteria, and no shocker, the mouse lived. Well, he then injected mice with a deadly bacteria, and no surprise, the mice died. Well, he then injected the mice with the deadly bacteria, but before he injected them, he heated the bacteria and thought that would kill the bacteria, and he was right. The bacteria was killed, so the mouse lived. The mouse was not harmed. And here's where it gets interesting. He then had a mixture of non-deadly bacteria mixed together with the deadly bacteria that had been heated. He was expecting the mice to live, but was surprised to see that they died. He figured out that bacteria, the deadly bacteria that had been heated, they have DNA in them. That DNA was transferred to the non-deadly bacteria that were still alive. The non-deadly bacteria became deadly. And we learned that bacteria, through this experiment, that bacteria can transfer genetic information. And this also taught us that DNA is the genetic material. This was at a time where we weren't quite sure. And so ultimately, data is going to be gathered by what we call the scientific method. Now, we're going to go through the scientific method in more detail. So let's move on to that now. So here we have the scientific method, very general definition of the scientific method. It's a series of steps that we use to collect information and to solve problems. And it begins with number 1, asking a question or identifying a problem or making an observation. So we're going to go through a fictional example of this in just a moment. But once you identified a problem, that leads to creating a hypothesis. So constructing a hypothesis, which is just an early answer. A hypothesis is what you think the answer is to the problem that you've just witnessed. After you have what you think is the answer, that's called the hypothesis, then it's time to actually do the experiment. The experiment is going to produce you data. That data, of course, has to be analyzed. And then once you've analyzed the data, you can draw a conclusion. Does your conclusion support what you originally thought? Does your conclusion support your hypothesis? Follow the arrows there. If your conclusion does support the hypothesis, well, then you still got to repeat the experiment. Repeat it. Perform the experiment again, if it's possible to perform the experiment again. And then what about the other side? Well, what if your data is not supportive of your hypothesis? Well, then you kind of go back to the beginning and you construct a new hypothesis and you kind of start all over. So this right here is the scientific method. Let's go through the scientific method using a fictional example. Okay, let's actually look at the first 2 steps of the scientific method on this one slide here. Step 1 is observation, or identifying a problem. And in our animation, we have a young lady laying in bed with headphones on listening to music. So the reason I have this animation, and this animation is going to kind of be the basis of this video here for the rest of the video. In our example, in our pretend fictional example, maybe she makes an observation. Maybe she accidentally fell asleep listening to music a few times and she seemed to sleep better through the night. So that's her observation is, you know, I seem to sleep better when I play relaxing music throughout the night. And maybe she's sleeping better because of the music. Maybe it's some other factor, but that's just something that she noticed. That's a problem that she noticed. So then step 2 is write a hypothesis, create a hypothesis. Typically what we're going to show you is it's an if-then statement, and an example of this might be if there's relaxing music playing, then I will sleep longer. You might often see if, then, because. If there is relaxing music playing, then I will sleep better because the music puts me in a calming state where I'm able to relax and sleep better. So that's what we mean by an if-then statement. And that's generally created step 2 in our hypothesis. Well, let's move on to the next step. Okay, so now we move on to the actual fun experimental part of the scientific method. And this is where we actually design an experiment. And when we design an experiment, what we're going to see is that there are 2 parts to an experiment, 2 groups. The first group is what we call the control group. And what's so special about the control group? Nothing. Literally nothing. The control group is the group of test subjects that receives no special treatment. The purpose of the control group is we're going to use it as a comparison. Well, what are we comparing it to? We're comparing it to the second part of an experiment called the experimental group. And notice from the picture here, the picture on the left, picture on the right, they're exactly the same because the control group, the experimental group, you set them up exactly the same, but with one little difference. In our animation, there she is listening to music. There's that one little difference. The one little difference between the control group and the experimental group is what we call the independent variable. It's the one factor that's different. All other factors are supposed to be the same except for what we call the independent variable. The independent variable is the factor that we're testing. In this fictional study here, we're testing whether or not music affects our ability to sleep. Well, during the course of this experiment, maybe she records herself for a month, records the amount of sleep that she gets for a month with music and the amount of sleep she gets for a month without music. Well, that's going to generate data, and we call that data the dependent variable. And I hope you see why it's called the dependent variable. Because the amount of sleep she gets, which is the dependent variable, because that can be recorded. The amount of sleep that she gets depends on whether or not she listens to music. So I hope you see why it's called the dependent variable. So anytime you're gathering data in a science experiment, maybe you're measuring the heart rate of people, maybe you're measuring the blood pressure of people, anytime you're measuring something numerical, that's going to be your dependent variable. Let's move on to this situation in a little more detail. Okay, so let's look at the control group versus the experimental group in a little more detail here. Here we have our experimental group, and we have the same person maybe recording the amount of sleep that she gets over the course of 1 month. So she's kind of going to set up 2 experiments here. And during her 1 month of recording her sleep, she's also exercising regularly. And during the 1 month where she's recording her sleep and exercising, she's also eaten very similar meals in this 1 month period. You know, well-balanced meals, of good balance of carbohydrates and proteins and lipids. And the one difference is, if you just notice, we added earphones with music. So the one difference between the control and the experimental group is in the fact that she's listening to music. All other factors are the same in this case. So let's pretend that after 1 month of recording her sleep, she's averaging about 6.2 hours of continuous sleep every night. And pretend that for 1 month while she's recording her sleep, she averages 7.5 hours of sleep per night when she's listening to the music. Well, something had to cause that extra sleep. And so, by the way, that the data that we just collected is what we call the dependent variable. And I hope you see why it's called the dependent variable. The sleep depends on, and that's why it's called the dependent variable. The amount of sleep depended on whether or not she listened to music. And so if I were to ask you, okay, examine the data. Does the data support the original hypothesis that this woman had? I hope you would say yes. Since all other factors are the same, the music must have caused the extra sleep. So granted, this is very much a simplified experiment here. If this was to be done for real, yes, there are other factors you would have to control besides just exercise and food. I'm just kind of using this to hopefully illustrate a point. Let's move on. Okay, let's move on and let's try this situation. Again, let's pretend it's kind of the same situation. Let's say the lady's going to record her hours of sleep for a month, and so in the control group on the left, no music. The experimental group on the right, she's listening to music while she sleeps. And notice how during the day for 1 month, however, they're doing different exercises for that 1 month period. Also, the woman's eating different meals during that 1 month period where she's recording her sleep. Well, if I were to show you that this data right here, pretend that the control group on the left, she slept continuously for 6 hours, and the experimental group on the right continuously for 8 hours. If I were to ask you, does the data support this original hypothesis? I hope you see something very different in this situation. In this situation, we can't say yes or no. Does the data support the hypothesis? We don't know. The data would be considered invalid, and I hope you see a reason why. There are too many variables in this experiment. She has the intended variable, independent variable, of sleeping with music and sleeping with no music. There's a second variable with different amounts of exercise, and there's a third variable with changing the food. These are all possible factors that could possibly explain why the woman received an extra 2 hours of continuous sleep. So when you have more than one variable, you really can't pinpoint your explanation. There's other possible explanations. And that's the importance of having only one independent variable in an experiment. Okay, so here's a little practice story problem. It says the United States military wants to see if soldiers with only 4 hours of sleep can operate at the same level as those who normally get 7 hours of sleep. 100 soldiers are allowed to sleep for 4 hours a night, and another 100 are allowed to sleep for 7 hours a night. During the day, the soldiers are tested for their marksmanship on the firing range. Well, go ahead and pause the video and try to answer these 4 blanks. I'm going to go over the answers in 3, 2, 1. So for naming the control group, I hope you said, well, that's the soldiers that get 7 hours sleep, because the control group is the group that gets the normal. And in the story it says, normally get 7 hours of sleep. That means the experimental group are the soldiers that are only getting 4 hours sleep. The experimental group is the group that we alter. It's the group that we're changing. And what we're changing is the amount of sleep. And so that actually answers my independent variable question. What's different between the two groups of soldiers is the amount of sleep that they're given. That's what we call the independent variable. What's the dependent variable? What's being measured is the score on the firing range. So this little story here, I have a few other stories, so let's practice. Here we go to the next one. Okay, so here we have a farmer with 2 bags of fertilizer, and the story says this farmer wants to test a new fertilizer on his crops. So he sections off 2 large areas of his field. In section A, he waters his crops as usual and uses his normal fertilizer called Grow-Right. In section B, he waters his crops as usual but adds a new experimental fertilizer called Evergrow. So after 1 growing season, he records the growth of the crops. Well, go ahead and pause the video and try to answer these 4 blanks. Go ahead and pause the video. I'm going to show the answers in 3, 2, 1. So for naming the control group, I hope you would say, oh, that was section A. Those are the crops that were given Grow-Right, because the control group is the group that receives the normal. And in this case, he's always been using Grow-Right. The experimental group would be section B, the crops that were given this new factor called Evergrow fertilizer. So that's the experimental group. So the independent variable, if you recall, it's just the difference. What's different between section A and section B? What's the type of fertilizer that he used? And lastly, the dependent variable is the data measured. How does he know which fertilizer worked better? He has to record and measure something, and what he's doing is recording the growth of the crops. So there's another example. Let's go on to the next example. So here is another example. Here we have a young student, and he wants to know if his new study method is more successful than his traditional study method. So for 1 month, he studies for his classes using his traditional study method. The next month, he studies for his classes using this new, maybe better study method. He's not sure if it's better yet. And so at the end of this testing period, he simply compares his grades. So just like the other examples, pause the video, try to answer these 4 blanks. I'm going to go over the answers in 3, 2, 1. So for naming the control group, I hope you said that's the 1 month where he was doing traditional studying. So maybe he was making flashcards and outlining his textbook, whatever his traditional study method is. The experimental group, that would be the 1 month where he was experimenting with a new study resource. Maybe he was doing online tutorials and online simulations. So I hope you see the difference right there between the control and the experimental group. So it says name the independent variable. What's different between those 2 groups? The difference is the study method. That's what we call the independent variable. It's the difference between the control and the experimental group. And how does he know if this new experimental method worked? What data is he collecting? He's comparing and collecting his grades. Again, granted, if this was an actual science experiment, yes, there would need to be more variables that are controlled, but I hope you see the point that I'm trying to make. Okay, here's the last example. Pretend that the city of Los Angeles wants to know if there's a connection between physical fitness and air pollution. 50 volunteers from the mayor's office agree to be tested. First, they're asked to ride a stationary bike for 1 hour in a pollution-free air chamber. A week later, the volunteers return and are again asked to ride a stationary bike for 1 hour in a chamber filled with air pollutants common to Los Angeles. Their heart rates are monitored throughout this 1 hour bike ride. Pause the video and try to answer those 4 blanks at the bottom. I'm going to show the answers in 3, 2, 1. Okay, so this one might have been a little tricky. The control group are the people who breathe the polluted air. And at first that kind of seems backwards, but then we realize, well, because the control group is the group that receives the normal. And in Los Angeles, it's normal to breathe fairly polluted air. Los Angeles is always either top 3 in the nation as far as most polluted air. For the experimental group, what's different is the volunteers who breathed clean air. So that's our factor right there, because again, clean is not the normal. And so that makes the breathing the clean air something different. That makes it the experimental group. Name the independent variable. I hope you said, well, the quality of the air that is being breathed is the independent variable. That's what's different between the control and the experimental group. And the data recorded, the dependent variable, the data recorded, it's their heart rate as they pedal on the stationary bikes. So I hope these examples helped. Let's move on. Okay, so let's get back to the steps of the scientific method. The 4th step is what we call data analysis. And it says data from the control group is compared to the experimental group. In the graph, you can see the data. The data that we said a few moments ago was that the control group without music got about 6.2 hours of sleep per night, and the experimental group with music got about 7.5 hours of sleep per night. So there's the data side by side in a nice readable graph. We're comparing the two. And you can hopefully see that, and we mentioned this a few moments ago, that the data seems to support the earlier hypothesis. Now, one thing I want to mention is that the hypothesis will either be supported or rejected by the experiment. It's not going to be proven. So I hope you're not going to look at this data and say that it's proven that music gives extra sleep. It's not proven at this point. It's supported at this point, yes. But by no means are we going to call it proven. It hasn't been repeated and retested by others, so we're not going to call it proven yet. Let's move on. And then we have the 5th step, the conclusion. So in this step, like it says, your findings could be shared and repeated by others. A second experiment, a third experiment could be designed by others. Not necessarily using the same lady, but the point is that others would have to repeat this, or perhaps even the person who originally designed this experiment could repeat it themselves. But that information, that experiment, would then be shared by others, so then they could also repeat it as well. And over time, perhaps, just perhaps, and I'm not saying this happens in a month or a year, it could take decades perhaps, but over time, a hypothesis could eventually become a theory. A theory develops over time. You know, in the picture, we have kind of a picture just summarizing Darwin's idea of natural selection. Today, Darwin's idea of natural selection is very much a well-established, accepted scientific theory. But in 1859, when he wrote the book On the Origin of Species, this was really his hypothesis at the time, that organisms with advantages would survive better and pass on those advantages to their offspring. And so hypotheses, if given are able to stand the test of time and intense scrutiny, eventually could develop into what's called a theory. Well, both theories and both hypotheses will change and can change based on new information. There might be new information that completely redesigns how we view natural selection. Maybe not. It's been 150 years of people trying very vigorously to discredit and disprove natural selection, and they haven't been successful. So natural selection looks like a very strong scientific theory. And so there you go. If you're in my biology class, pause the video and try to answer these questions here. I'd be happy to check your answers before school or after school one day. Go ahead and pause the video. Good luck.